Hello everybody, today we are going to discuss the Heisenberg's uncertainty principle. Alright, so basically, to understand this concept, you must know about the Bohr's model of an atom. Okay, so it is a step further. So after studying the Bohr's model, we come to Heisenberg's uncertainty principle. So what is the principle? Let us discuss the principle, but before that I'd like to discuss some things. For example, let this be a ball. Say this is any common ball that everyone has encountered, although it doesn't look like one, but let's consider for the time being. And this ball is moving with certain velocity v, and this ball also has mass m. Now we will say that the momentum of the ball is mv, and to make things more concrete, the mass be like, I don't know, what should be the mass of a ball. I know 1 kg is maybe too much for a ball, but let us consider that, I don't want to do all the calculations. So what is the velocity? Let the velocity be 1 meter per second square. Okay, that would be way too simple. Let it be 6 meter per second square. It's still simple, obviously. So the thing is now that the momentum of the ball is this 6 kg meter per second. Sorry, not second square. I said second square, but I have written here meter per second for velocity, right? So this is the case. So we know the momentum of the ball. We can calculate the momentum of the ball, and also at the same instance we can tell where the ball is. For example, if you are, say, here, if your friend is somewhere over there, who is 100 meters away from you, and suppose the ball is somewhere over here, and you can measure at that instance by using simple ruler or something, and you can measure the distance of the ball, the horizontal distance. The ball is away by the horizontal distance of the ball from you. Let it be 80 meters. So there's no problem, right? We can calculate both the momentum and the position of the ball, right? At any given instance. Another example. Let me take another example. Let me take another example. Right. Say we in everyday life we see cars moving in the road, right? So we know the car is moving with certain velocity, right? We can find out the magnitude of the velocity, which is obviously the speed, which is called the speed, right? And also we can know the position of the car, right? For example, say the car is like somewhere 100 meter away from this tree, right? To measure the position, we'll have to consider a reference frame. Let the tree be our reference frame. So if this is the origin, let the tree be the origin. Then the car is at a position of minus 100 in the x-axis. And since we know the velocity, and suppose we also know the mass of the car, we can find out the momentum. So I have just given 2 examples, right? In our everyday life, where we can calculate these 2 things simultaneously. But now coming to the principle, this principle says that there's no way that you can calculate both of these things simultaneously. Wait, but how did we calculate this? I mean, for the car moving, we right now just calculated that, and also for the ball. But what does the Heisenberg principle say? It says that you cannot do that. It's not possible. Well, yes, it's not possible. Now you might think, how is that? Right? It goes against our intuition. Well, this is true mainly for. Actually, it is true particularly for the very, very, very small particles, which is at the quantum realm. So as to say, at the atomic level. Particles at the atomic and subatomic level. For example, it is very true for a electron, right? It's very true for electron. So without further delay, let's come to this explanation, of this principle. This principle basically states that this is the uncertainty in position Okay, this is the uncertainty position. So this uncertainty in position, if multiplied with the uncertainty in the momentum, is greater than or equal to some constant, and this constant turns out to be 4 h by 4 pi, right? In some other textbooks this might be in different form, this formula might be in different form, but this is the main idea behind the principle. Okay, so you can rely on this formula as well, and in many textbooks you'll also find this formula as well, right? So this is a common formula, more common form of this principle. Well, now, do you remember I told that the Bohr's model of an atom is prerequisite to this topic? Well, this is why I said it. According to the Bohr model, this is the nucleus, okay, which is positively charged, around which negatively charged electrons, right, revolve in well-defined energy levels or orbits, right? So Bohr model actually gives us an accurate position for the electrons. Lets us calculate the accurate position of the electron. For example, by using this formula, as we know, 0.529 n square by z angstrom, we can calculate the radius of the orbit of the electron, so which also translates to that we can know the position of the electron. And by using the formula for velocity, 2.18 into 10 to the power 6 into 10 to the power 6 z by n meter per second, we can know the velocity, and if we multiply the mass of the electron, we can know the momentum. You might be knowing z is the atomic number. In case of hydrogen it is 1, and n is the number of the shell number, right? So Heisenberg's uncertainty principle says that since we cannot know this too accurately, Bohr's model must be wrong, that we cannot define both the velocity of the electron moving in a particular orbit and its distance away from the nucleus of the atom, right? So the picture that you can see here is the newer version of the model of an atom, okay, the quantum mechanical model of an atom, right? So the regions, as you can see over here, this is the region, let me use a different color. This is the region where the probability of finding electron is more, so hence more number of dots, more dots concentration you can see, and the dots concentration decreases as we go away. So basically these dots, wherever the concentration is more, the probability of finding an electron is more, right? See, now we are talking about the probabilities of finding an electron, right? And we are not talking about the accurate distance or like the radius of the orbits of an electron, because now we know, after the Heisenberg's uncertainty principle, that we cannot say surely that an electron is out somewhere over here, or electron is over there or there. It's rather a probabilistic concept only, that the position of an electron is probabilistic. We cannot just confirm 100% that it is over here, right? So basically you need to know that this is greater than or equal to h by 4 pi, and this is the Heisenberg's uncertainty principle, which also gives us a newer version of the atom, right? And by newer version I mean a newer model, and so this is the case. Yeah.